Welcome to another Zenit webinar. My name is Klaus Shipley, and I am a business developer at the company. I have the opportunity to introduce today's session, and I actually find the topic quite interesting because, as many of you may know, keeping Alfresco available, performant, and responsive is the main way to make your customers happy. Luckily for us, we had a 93% customer retention rate over the past 5 years. So I think we must be doing something right. This leads me, of course, right into the topic for today's webinar, which is how to solve your toughest performance issues in Alfresco. So I am delighted to show our viewers the tools that help us get the job done. Our first speaker is Ronnie Timmermans. He is the CEO of Zenith, and he has been working with Alfresco for over 14 years. He will use his valuable insight to introduce the agenda, but more importantly, he will explain the goals and values behind our monitoring solution. And towards the end, I believe we'll also preview a little bit of the roadmap. Our second speaker is Hannes van Kamp. He is a very talented DevOps engineer in his own rights, and he's currently the team lead for one of our largest customers in Belgium. This customer has almost 100 million documents in their repository, and Hannes and his team keeps their system up and running. Hannes will give an overview of the technology we use to build our monitoring solution, and he will also give us a live demo. With that being said, I would like to pass the floor over to Ronnie.
Great. Thank you very much, Klaus. The title of today is how to solve your toughest performance issues in Alfresco. And of course, ops and observability plays a role. And there's a short and a long answer to this question. I think the short answer is by avoiding them. And the long answer is, what do you have to do to avoid really those toughest performance issues? We believe more and more, and it's a general trend in the industry, is that observability is key to avoid problems and to solve them wherever they would still occur as quickly as possible. And Alfred Ops is there to help you to create that observability and that insight so you can avoid your toughest performance problems, maybe also availability problems. It's a balance of qualities in your architecture. So for the agenda of today, there's one slide on the top 6 qualities we believe that any ECM should bring, and in particular, what we bring to Alfresco. There's a second topic on open source monitoring for Alfresco. How do we do that? Why is it open source? What's in it? After that, Hannes will take over. We'll speak about the technology stack. We'll also give a live demo of the tools that we have composed and configured and integrated to monitor Alfresco and to ensure the ops part of any good DevOps team. And I'll be speaking quickly about our ops roadmap, tools and use cases that you can expect. There's some short Q&A afterwards, depending on the number of questions, of course. So about those top 6 qualities, and we call them now and then the DNA of our Alfred tooling. In order of, let's say, if you look at the food chain at the very top, we believe that clarity is key in any solution that you would create. And there is clarity of user interfaces as indicated in the stack on the left-hand side. But it's not just about user interfaces, it's clarity of API, clarity of documentation, clarity of architecture. So clarity everywhere helps to create insight, and insight helps to avoid performance problems. Number 2, so very close in the food chain, is performance. And we have a 3 seconds rule. It's not always that we can guarantee it, but we will not rest before we have reached that level. 3 seconds rule says that any query that a user performs on the system, 95% of queries that the user performs on the system should return within 3 seconds or better. I think that's a benchmark, because if users have to wait longer for results, they get bored, their attention gets scattered, it's not productive. It's very agreeable if you have very quick results on your screen. I think that's what we should achieve with Alfresco and guarantee. Availability, that's of course a base value. These days, 99.9% becomes the standard, and we even have customers that ask us to create zero downtime environments in which you can do upgrades without any consequence or impact for the end users. Somewhere below that, but not not unimportant, is your architecture and the agility of your architecture, because you can guarantee availability, performance, and clarity, but the system is changing. The system is changing all of the time. It's growing in documents, it's growing in usage. Your business is changing, there are other integrations. So you have to juggle those goals of clarity, performance, and availability within a changing environment. And that is what a good architecture brings to you. And then the two pillars of governance and security are never to be taken for granted. Governance is really important. It is about making sure that your data is complete, your data is correct, your data is available. Somebody controls who changes your data and who can access, of course, documents and metadata. And on the right-hand side, security. You need a gateway, you need lots of things. You need an encryption. You must make sure that your archive is secure. So if you say that performance is part of a balance, a quality balance that we have to create, and we want our customers to be empowered, and our users and everybody in the Alfresco community to be empowered so they can make the choices and they know what kind of trade-offs they're making. If I want to ingest 1 million documents in an hour, that will have an impact on the search performance that you will have, because you can only use a resource once. And those kind of trade-offs should be explicit, and the customer should be empowered to make them. And that's architecture as we see fit for Alfresco. Alfresco is not slow. We are talking here about performance and how to avoid performance problems. Of course, we see that Alfresco is seldom operating at peak performance. Sometimes customers could complain about performance. You might have like peaks, garbage collection, times at which performance is not optimal. It is complicated. You need tuning, caching, and tweaking. And you need to do experiments, and that's the way how to learn it. There is no golden book and standard, no Excel spreadsheet to do your resource allocation and quantification. You need to do experiments, and that's part of learning how Alfresco behaves in particular customer circumstances. And those experiments will help you to create a system that allows to avoid performance problems. And the experiments, of course, contribute to the observability. It puts some science into the art of managing Alfresco. As you know, observability covers four topics. That is, you would collect log information, you collect metrics information, you collect tracing information, and also you collect availability information. Those four give you great observability. If you talk about performance, it depends on factors inside and outside of Alfresco Content Services. There is a database. The database needs to have enough resources for connections. It needs to have an optimized execution plan, query plan. There is Solr, that is a topic and a domain of performance in itself. There are many ways how you can tune and improve Solr, including caching that we apply for our largest customers these days. There are the Alfresco caches. There are many of them. And there is also measuring the usage and the type of queries that you launch to the system. Of course, if you do a lot of wildcard searching in Alfresco, you will create queries with 1 million results. And that just takes a lot of resources away from useful activities in your Alfresco. So there can be a little bit of education as part of performance tuning as well. And performance is always this balance between resources, tweaking and tuning. And how much resources do you need? Huh? Do I need 5 Solrs, 2 Solrs, 3 Solrs? Well, the best thing is to measure the impact of using instances, using resources, and from that experience, learn how to optimize an Alfresco environment for a customer, be it hosted, be it on-premise, whatever you would like. And observability is, again, this process of watching, learning, experimenting, and improving. So you can get Alfresco to perform really well, but it requires work. Alfred Ops is our open source monitoring tooling for Alfresco. It is even a bit more than monitoring, but monitoring is the main task and objective of Ops. This is the whole stack that we have built that allows us to create that observability into Alfresco. And it's an ongoing story. It's never done. You can always do it better, learn more, measure more, and learn to measure what is really relevant to the performance of the system. We have been using this for a number of our larger customers, and that is on-premise or hosted. With Accenture, we did for one of their larger customers with 15,000 users an audit, and we also helped them to put in place a number of observability ops tooling to help that customer scale to 15,000 users. There's the bank BNP Paribas Fortis, where we have to ensure a very high availability level and a very good performance. So the ops tool is being used as well. And at the bottom, we have 3 of our premium important insurance customers that we're serving with ops tooling, that we're helping or integrating that with part of their tooling and adding Alfred Ops in the stack, so they have a closer eye on how their solution is performing. In a nutshell, we instantly assess the health of your content platform. And I think once Hannes shows and tells about the solution, you will see what kind of metrics and parameters that we're following up. They're literally in the hundreds of parameters that are important of different kinds. It's not just assessing health, it's also about urgent interventions or proactive maintenance. So these tools really help you during an intervention to focus on the real problem, to fix that, and in the future, of course, to try to predict and anticipate problems and avoid them. Avoidance is the best solution for how to solve your most urgent performance problems. We also have real-time alerting. That is important. You can do a lot of metrics collections and logs, etc., but you want to be triggered. We don't want to be in a constant state of alert. We only want to be alerted when there is a problem, but that should be happening in real time. We should be, the ideal is to see a problem happening before it actually occurs, so we can intervene before it has impact on our customers. This is the ideal state. Not sure whether ever to be reached, but we want to progress on that route. And that took me through the introduction from my part, and Hannes will give you a closer look at the suite and the possibilities and the tools, and I'm looking forward to his presentation as well.
Thank you, Ronnie. So, hello everyone, my name is Hannes van Kamp, for those who will join later, and I will introduce you to the Alfred Ops technology stack, which consists of Prometheus, Grafana, Kibana, and Alerta. We'll start with Prometheus. Prometheus is an open source monitoring and alerting tool responsible for both collecting and storing system and application metrics from the Alfresco platform. It does this via a pool model over HTTP, known as scraping from either a built-in or standalone Prometheus exporter at a fixed interval, for instance, every minute. More and more applications are supporting Prometheus out of the box, including Alfresco, Enterprise Edition only though, in version 6.1. Another example of out-of-the-box support for Prometheus is HJ Proxy, an open source load balancer, which we use extensively to set up high availability for Alfresco. At Xenith, we've also created a custom Prometheus exporter called Alfred Telemetry, which is part of the Xenith open source tooling, meaning it's publicly available on our GitHub page. It integrates various components of the Alfresco ecosystem with micrometer and application metrics facade that supports numerous monitoring systems such as Prometheus. Next, we have Kibana. It's an open source data visualization dashboard tool for Elasticsearch. Data stored in Elasticsearch is coming from an Elasticsearch file-based agent responsible for collecting and parsing the application logs. In our setup, for example, file-based is parsing the local container logs, and an Elasticsearch remote agent to collect and parse the system view channel logs. Combining everything together, it allows for centralized logging of both your system and application log files. We also use Kibana specifically to get an insight into the HTTP requests that are being sent to Alfresco, both from status code and response times perspective, and for searching and investigating application and system error messages on the Alfresco platform. Next tool is Grafana. Grafana is an open source visualization web tool used to visualize the application and system metrics from your Alfresco platform. In our case, stored on a Prometheus server, but know that Grafana has support for many other different data sources, like, for example, Graphite and Postgres as well. We have created a dedicated Alfresco dashboard, which provides a very comprehensive overview of the most important metrics of an Alfresco platform, going from some quick facts about the Alfresco platform like uptime and heat usage to more detailed metrics like GVM memory, GVM load, database connection pool usage, to name just a few of the metrics visualized on the dashboard. In other words, the Grafana dashboard allows for quick insights into potential bottlenecks of your Alfresco platform. And lastly, we have Alerta. Alerta is an open source monitoring tool which provides us with a quick overview of all the monitoring alerts coming from multiple sources on one single screen. Alerta also allows us to create different severity levels and identify them with a distinct color, which in turn helps us to easily distinguish between production and acceptance alerts, for example. Another helpful feature of Alerta is the fact that we can take action on monitoring alerts. We could, for example, acknowledge an alert, useful in case an alert is about a known problem that is already being worked on by an engineer, and therefore we don't want to sleep anymore on the Alerta board. That helps us to empty the Alerta board so we can concentrate on any new alerts that might appear in the future. Then it's now time for the live demo. Now you should be able to see my screen. So for this live demo of the Alfred Ops technology stack, I simulated the database issue, which, as you can see, triggered several alerts to appear on our Alerta board. Note how each severity has a distinct color. So we have, for example, the critical in red and warning in yellow. So we know that the criticals are the ones we have to tackle first. They're also sorted by severity. So yeah, as I said, critical are on top because they're the most important ones. If we click on one of the open alerts, we can see more details about the alert. For instance, the creation time. So we know when the alert first appeared, and the last received time. So we know if the alert is still appearing or not, still firing or not. So with that, we know the total duration that the alert is initially opened, and for how long an incident might already occur. And when we go to the history tab of this alert, we can also see potential state changes of an alert, and that's useful in case an engineer takes action on an alert or detects state changes, also called flapping, as in an alert changes quickly from open to closed. In Alerta, we can also perform multiple actions on an alert. If we look at the icons here on top, we can, for example, acknowledge an alert. And if we acknowledge an alert, it of course appears in the history, and then we have acknowledged it, operators acknowledged it. And then if we go back to the home page, the alert will have disappeared from the board. And that helps us to empty the board so we can concentrate on any new alert that might appear in the future. Next, let's have a look at Prometheus. That's the source of the monitoring alerts currently being displayed on the Alerta board. Here we see the alerts page of Prometheus, so that contains a configuration of all the alerts. And as you can see, we have configured numerous of both system and application alerts in Prometheus, so that you're always aware of your Alfresco platform issues. So on the top here, we see Alfresco specific alerts, like GVM usage, GDBC, so database connections and such. We have currently one alert firing, the one we also saw previously on Alerta, the read-only alert, meaning Alfresco is currently in read-only modus. We have container killed alert, so something wrong with some of the containers running on this system. We have Elasticsearch alerts. We are monitoring Prometheus itself. For example, we have Prometheus target missing firing at the moment. That's also very important because that actually means that currently we're not receiving any metrics for, in this case, Alfresco and PGWatch, so the Postgres database. We also have configured several alerts for HA proxy. So we monitor if there's any HTTP 400, 500 errors happening or not. Or in case, for example, the server has disappeared as a backend server on HA proxy. Next, let's go to the targets page. So the target page of Prometheus shows us currently what targets are being scraped by Prometheus. So Prometheus is scraping all the targets, in this case, every 60 seconds, every minute. And we see, for example, first one, Alfresco, is currently still down. So there is a current Alfresco, so it cannot scrape the alerts. Next to that, we have a black box exporter. That's another exporter that we use to perform health checks of Alfresco, because the black box exporter can probe any HTTP request URL and check the status. Now, after Prometheus has finished scraping the metrics of each of these configured targets, we can explore these metrics by going to the expression browser, which is the graph page here. And we can query and visualize the metrics collected by Prometheus. So for instance, let's say we want to view the latest GVM memory usage statistics of Alfresco. We type in the metric name, so GVM memory used bytes, for example, this one, and we hit enter. We see, for example, here 8 metrics being returned from, in this case, Solr. It's also possible to quickly generate a graph for any Prometheus metric. So because the table doesn't say much, we can also just generate a graph by clicking here on graph that speaks more than a table. And there we can, for example, see that there are several heaps, and the one that is fluctuating the most is the one in yellow. the G1 hidden space, but that's to be expected since there's garbage collection runs every minute. Now, as you can see from this page, the graph functionality in Prometheus is quite rudimentary. So that brings us to our next tool, Grafana. So from this homepage, Grafana, we can already see that we have configured several dashboards to give you a better understanding into the system and application metrics for an Alfresco platform in terms of capacity and performance reporting. For instance, let's take a look at the Alfresco telemetry dashboard. And so here we can see, first of all, some quick facts about Alfresco, as in the uptime of Alfresco and the overall heap used and non-heap used. But there's more detailed metrics on this dashboard as well. So if you click open GVM memory, we actually see the GVM heap usage and see it go up and down because of the garbage collection runs. And speaking about garbage collection, we also get detailed metrics about the garbage collections itself. So that's very useful to know. So we see, for example, here an increase in garbage collection pauses. So that's very useful to know and can also impact the performance of Alfresco. We also have database connection pool. That's also a very useful metric since that can indicate potential database issues. And what we usually see in case of database connection pool issues, or database connection issues in general, is that actually the active number of connections will start growing up to the max, and then Alfresco will basically stop working completely. Another helpful Grafana dashboard to look at is the host metrics dashboard. It visualizes the key system metrics of a physical or virtual machine, like CPU usage, memory, disk space. And that helps you to better understand your current overall system usage and improve your capacity planning, for example. Also note that we can easily zoom in on a panel on a graph if you want to. For example, on disk space used, we see here a small peak, and so we can zoom in like so. And then we see, for example, that the root file system here jumped up to from 69 to 92%. And finally, let's have a look at Kibana. So, as I already mentioned, Kibana is part of the Elasticsearch stack. So that also includes FileBeat agent responsible for collecting and parsing application logs, and a JournalBeat agent to collect and parse the systemd journal logs. For this demo, we only focus on Kibana. I will not go into any more details about the other components of the Elasticsearch stack. So here I will just show you first a predefined Kibana dashboard that can give you quick insights and into HTTP response code on our Alfresco platform. So we have the Xenit dashboard HA proxy overview. That gives you an overview of the HA proxy front end, back end. So we have several backends on this HA proxy as Alfresco itself, but also to Alerta Grafana. You see the response codes, as in how many were successful, and with status code 200, but we also had some 500 entries, so service unavailable, bad request and such. So it gives you insights on what's happening on your Alfresco from a request point of view. And on this dashboard at the bottom, we get even more details, as in we can actually see the request itself, the raw request line. So if it's a post or delete, and whether or not it was successful or not, plus the size of that request. Another example on how Kibana can assist you is by providing an easy-to-use interface for searching and investigating error messages on the Alfresco platform. So we can do that by going to the Discover page for Kibana. And that allows us, for example, to query for NV-log messages stored in Elasticsearch, and we can, for example, filter on a very common error keyword like exception. So if you type in message exception, then we see, for example, it returned one log line saying exception, operation is unsupported. That's actually coming from, if you click it open, you can see that this exception was logged by Alfresco in this case. Surprised. So to conclude this live demo, let's do a short recap on the Alfred Ops open source monitoring suite that I just demoed. So we use Alerta to provide us with a quick overview of all the monitoring alerts coming from multiple sources like an acceptance and production environment on one single screen. Alerta also lets us take action on alerts like acknowledge, so we can concentrate on any new alerts that might appear in the future. We have Prometheus, the tool responsible for collecting and storing system and application metrics from your Alfresco platform, where we have configured numbers of both system and application alerts so that you're always aware of your Alfresco platform issues. Note that Xenit also created a custom Prometheus exporter for Alfresco called Alfred Telemetry, available publicly on GitHub. We also presented Grafana, the tool to visualize the application and system metrics for your Alfresco platform. It contains, for example, a dedicated Alfresco Alfred Telemetry Dashboard, which provides a very comprehensive overview of the most important metrics of your Alfresco platform. And lastly, we have Kibana, the data visualization dashboard tool for Elasticsearch, which gives us an insight into the HTTP requests that are being sent to Alfresco, both from status code and response times perspective, and allows us for searching and investigating application error messages on our Alfresco platform. I will now give it back to Ronnie.
Thank you very much. That was lovely. I think that's really, that was the main dish of the presentation of today, to give you really an insight and an overview of the capabilities of the platform, of the Ops platform that we're building. Of course, we built those on common tools. Everybody knows, or many people in the open source community know about Kibana, know about Grafana, we know about Prometheus, but there are literally hundreds of measurement points, metrics, and log analysis routines implemented in this platform. So it's a reflection, and that's also our endeavor of 13 years of operational experience with Alfresco by running it with our customers, and we keep on enriching it. Now, as I said, it's a never-ending story. It's a continuous process. So we have some stuff on the roadmap and some use cases that I would like to explain. Let's look at 4 things. Yep, that we have on our roadmaps on tools and tricks. First of all, we're working on a Solr Tracing and Insight module. I'll be saying a little bit more about that in the coming slides. It times end-to-end requests, so it gives you insight in search performance, helps you, for instance, if you have a sharded setup. And we're going to roll this out in production with a Belgian insurance company, where we have 140 million documents, more or less, in the archive. The Alfred not heat processor, health processor. You can make heat maps, but it is a health processor. It's a system to loop over Alfresco to check completeness and correctness of Alfresco data and artifacts in your Solr index versions, renditions, thumbnails. It's pluggable. We have a French insurance company. We have other customers, but we have a French insurance company at more than 60 million documents, where we actually use this for a real world production issue as to solve that. Some neat and nifty tools are the advanced Alfresco health check that we're building. What is the idea is that the whole ops stack can monitor the health and can do that in a very relevant way. So though Alfresco, one of the nodes of your cluster, is not running anymore, you will automatically restart it. Very often, that is the solution, the short-term solution to an operational problem. Of course, you will automatically make some dumps, etc. So to give you insight and observability in the problem, but it's just a very, very convenient way of doing that. But you should do it in a proper way, because otherwise the system is going to restart your Alfresco 10 times a day, and then it's not increasing availability, it's decreasing. So any tool, you have to make it very decent and very reliant before it really adds value. There's a golden oldie we have, Care for Alf. That's a tool for data control and batch repair. It does a lot of repairs and insight routines and just reusable stuff that we also deliver to our customers and to the community, has to be used as a service tool. And I want to give also a tip. The best of the rest, with all the respect for the rest, is the Order of the Bee support tooling. Is really also a great treasure trove of interesting monitoring tools. Now let me talk a little bit about Solr Tracing, because Hannes spoke a lot about metrics and logs files, but we didn't talk a lot about tracing. So what does tracing do? Well, it creates graphs in this form. This is a hit on Solr from Alfresco. So somebody is searching something, and we are looking into Alfresco and in Solr to get the results. As you can see on the left-hand side, we have three spans. First of all, the user interface of Alfresco is used, share, to formulate the query. That query reaches Alfresco. That's the second span on the left-hand side that you see. And Alfresco will query Solr. You can see the total times of those spans on the right-hand side next to the spans themselves. And this is a high-level view. What we can also see is that the query time is 119 milliseconds overall in Solr. Excuse me, in Solr, not overall. This is the real query time, and you see 154 milliseconds in total. So there is some additional processing in Solr going on. Let's look at the next one. If you do it very fast, it comes like almost an animation. But what do we see here? We see actually two charts being queried in Solr. So you look inside Solr, what is happening there? And chart number one, which you see on the right-hand side on the top, is being queried, and it returns one result in the query time of 58 milliseconds. The query was about a meeting, and this is a sharded setup. The other shard took more time. Fortunately, that's logical because it returned 5 results, which is not en masse either, but still, it took 82 milliseconds to return that result, which you see in the yellow rectangle highlighted there. Then if you look even further into why did Solr take 150 milliseconds and not 119 milliseconds? What did it do extra compared to looking at processing the queries themselves? Is that you can see that there is some prepare of the query. There's a process of the query. There's also spell checking whenever you would launch the query. All of these things are happening before the actual query has been launched. And there is also some faceting going on, because when you get a query result from Solr, it will also return you the facets to filter upon. So it has to do some post-processing on your search results. By the way, also very important to know that when you hit Solr, there are two parts in your query. The one is to execute the query, getting you the result nodes back, and then you will add the field values into those result nodes, and that's the get field span that you will see. So I think this gives great observability in performance and what's happening and how many shards you would need in such a thing. We built this by adapting the Solr HTTP client and exploiting the debug information that Solr itself actually provides you with. And this is where you can get in observability and tracing. This one, it's not, now it's spelled correctly, it's the help processor. That's the second tool that we have, a help processor. That means that sometimes the patient get a little bit sick. What does it do? It's a platform module that runs through Alfresco and which you can use and extend by plugs, plug modules. You can plug in extra modules. You can determine the checkers, the fixers, and the reporters that you have to be activated. You can use the infrastructure of the help processor, which is really like it's a continuous loop to check things, but you can extend it to do your own checks. You can do that without forking the help processor, so it's not intrusive. And even you can create very specific tests for yourselves, which are not reusable as such in the general Alfresco context, but which are very important for your particular case and problem. So that's a really nice tool, I think. What do we have out of the box as health checks? Content validation is all your content in the content store, according to the logical objects in your database. Solr index validation is all the content that should be indexed in your Solr indexes. Fixes for nodes missing in the index have been added. Fixes for nodes that are duplicated in the index, that can also occur, imagine. And Alfred telemetry, the Alfred telemetry reporter writes metrics to Alfred telemetry, so that can be sent to a monitoring system, as Hans explained previously. And we have the log writer that writes details about and healthy documents, so the Alfresco logs. This is the architecture. I will not go into detail here, but what you can see is actually it's a system of it plugs into the Quartz job scheduling of Alfresco, and then it will exchange nodes and information and batches as to make sure that your Alfresco infrastructure is complete, and your indexes, your Solr indexes, for instance, are complete and correct. So that brings us to the Q&A. If there are some questions from the audience, you're welcome to.
Yeah, we can address some questions. I see here the first one is about Grafana. And are the dashboard of Grafana also open source, JSON files?
Yes, they are available on our GitHub repository.
Okay, thank you. Another question here is, how do you generate the store data?
Sorry, can you repeat the question?
Yeah, how do you generate the store data?
Is it how much data do you generate?
The system generates the stored data, but maybe it's also about how we handle and archive and keep the data. I'm not sure who asked the question, so there might be some clarification.
I think the question is, how much data do we generate and how long do we keep it?
Well, that's something I think that we can talk about a little bit. Typically, how much data and how do you keep it?
It depends, of course, how many targets you have configured on Prometheus. But let's say you just are monitoring one Alfresco, one environment, let's say, then you should. In this case, on our demo environment, it's around raw size 30 gigabytes for storing the data for around 60 days.
Okay.
But that's all configurable, so we can keep the data longer, and actually, if it's production system, you should keep it longer for capacity monitoring. But yeah, okay, that's a good idea. Okay.
Okay, and I have another question. So, what are the most common performance issues in Alfresco, and how do you address them?
So as I already showed during the demo, one of the most common issues is that the database is not performant enough. And as I already mentioned, we usually see that by looking at the database connection pool that keeps on growing, and then in the end even brings down Alfresco because of, it's not performant enough. But then of course you need to have a look with your database administrator why the database is not performing as it should. And another performance issue we find often is that the heap usage is not, or the heap size is not configured correctly. That garbage collection runs are being triggered too often. So usually then we have to we have to increase the heap size of Alfresco.
Yeah. If I thank you for that, Hannes. If I can add something, is of course that Solr is also crucial in search performance. It's not like what is the biggest problem with Solr. It first of all depends, are you indexing only your metadata or are you indexing content and metadata? That makes a huge difference on the sizes of the indexes. And the sizes are one of the parameters that influence performance. Secondly, there are benchmarks and white papers from Alfresco that show if you go beyond 50 million documents, that you should be starting to shard the Solr indexes. And that is an art and a science. So what is the challenge there is to pick the system parameters well, to size your environment, to make sure that the buffers are correctly sized, and also to choose the right sizing sharding strategy. There are different, there is an ACL-based sharding strategy, a DBID-based sharding strategy. I think we applied a very smart trick at one of our insurance customers, where we made larger charts for older documents and smaller charts for newer documents. So you would be searching in smaller charts and have a lot of probability that you hit those small charts when you do searches, also for updates in those small charts. So there's a lot of best practices actually to scale those that Solr. But again, Hannes is right. Very often we forget the database. Some databases are better than others to regenerate their query plan automatically and optimize it, looking at the right indexes, etc. We've come across, I think, quite a bit of issues on the database level, because Alfresco has a very specific database structure, of course, which doesn't make life too easy on the database, on a standard relational database. But we are very much in fans of Postgres technology, and we feel that you can scale it if you know how to do that. You can go very far.
Any more questions?
No, I don't see any other question unless someone wants to raise now, but I don't see anything. Thank you.